What's going on YouTube? This is IPSec, and this video is pretty much just going to be an introduction of playing with a hex editor and parsing data out of an SSH key. It started off because of the response machine in Hack the Box, where the final step, you got this screenshot that you can see that had like the final 4 lines of an SSH private key. And this is a big enough information leak to if you have the public key that you can recreate the whole private key, which is crazy to me because private keys are generally around like 38, 40 lines. And it just takes 4 or 5 of those lines to have enough information to recreate the entire SSH key, which is awesome. And I know I've been guilty in writing pen test reports, taking a screenshot of a private key and like filtering the top half, thinking that's enough like information removal to be secure. But it turns out it's not, because you only need one number out of the private key if you have the public key to rebuild it. So let's just jump in. So to kick things off, let's just generate a key. So I'm going to do SSH-keygen-f for the file name. And then we're going to call this, let's call it unencrypted, right? And if we look at the key, most sane people, this is all they've really looked at when they look at a private key, is just base 64 data. Not many people have tried to unbase 64 it because it just sounds like a weird thing to do. But those that are curious may, right? So what I'm doing here is grep-v to remove the lines that begin with a hyphen. And we're going to dbase 64 it. So base 64-d, and we get a bunch of gibberish. And this is where most people would stop. They just go, okay, this isn't like ASCII data. Let's just move on with their lives. But if you want to actually parse this out, it's somewhat simple and a good like lesson. So let's do that. I'm going to call this unencrypted.pt for plain text. And we could view this in like XXD. And this is generally when I want to do something quick, how I view hex data, because it's good enough, right? But if I ever want to do a demo or something, like this is clunky just because like highlighting and things just, I mean, it's not pretty, right? For demos, I like using Bless. I don't really like Bless, but I don't know another good hex editor that I like using. The main feature I like about this is whenever we click something, it will tell us what offset we're at in the file. So it's very quick. If we highlight characters, it says how many things we've highlighted. So like the selection is 4 bytes. And the other thing that I absolutely love is when you highlight something, it shows other repeats. So that just becomes infinitely handy. And Bless does a good job at all of that, and it's free. One really funny thing about Bless, I installed this with just apt, and then Bless crashed. I noticed a crash dump had mono in it. So if we do which Bless gets installed to user bin Bless. If I do less on this, so user bin Bless, it's just a bash script using mono, which is pretty much execute .NET on Linux, and it's executing an exe. So apt actually installed an exe to my machine, which I just laughed at because I've never really noticed that before. And you can do file against it and see, yes, this is mono.NET assembly. But let's get back into this SSH key. So opening this up, we just have the hex. And if you go to OXDF's blog post on response, he does link to this blog. There's a lot of good information about just the format of it, but the most useful piece is this. That just explains all of the parts of a private key. So it starts with byte and then N, and this is going to be a null terminated string. And then we get cipher name, KDF name, unsigned integer 32, and that's going to be salt rounds. And we'll explain all of this, but a lot of people I know just read this and kind of stopped because they didn't understand what was going on. So let's break this down. The weird thing about SSH keys, well, there's a lot of weird things, but the first weird thing I want to point out is the only null terminated string, a null is 00, is the magic bytes or whatever they call this beginning thing, this open SSH key v1. That's going to be the only thing that's terminated by a null byte in this file. And it kind of throws you off because if you assume other strings are like this none right here, if you assume this is part of the termination of none, then you get off by 1 and just everything goes crazy. So don't ever think of a null byte as termination when processing this, unless it's the magic byte, right? So this just says it's an SSH key. And I think that's there so if you do a file against it, So if we do file unencrypted, it'll tell us it's an OpenSSH private key. If I do .pt, it just says data. So this isn't for file because, again, we decoded the base64. So it's just a fingerprint or something. Let's ignore that, I think. Sure. So the next piece. After this auth magic, we have string cipher name. And it doesn't really point out exactly how this is working. It doesn't say it's not null terminated or something like that. But there's a unsigned or a 32-bit integer, which is 4 right here. And that's going to be how it reads the string. So every time you read string or something like this, there's probably going to be a length that comes before it. And that's going to be 32 bits or 4 bytes. So we read 4 bytes and it says the cipher name is set to none, and that's because we didn't encrypt it. Then the next thing also involves encryption. It's probably going to be bcrypt if it's encrypted. If it's not, it's none. So we look again. We have 32 bits and none, right? So the next thing that comes after that is going to be an unsigned 32-bit integer that is going to be salt and rounds. And this gets a little bit confusing because we did not encrypt anything. So this is a length right here. Actually, 1, 2, 3, 4. This is the length right here. And since we didn't encrypt anything, it's 0, and then everything stopped. So we don't really see this because the length is 0. And then the next thing is number of keys, which if we go to this next piece right here, this is going to be the number of keys, which is just 1. Another odd thing about like private key files is you can put multiple keys in one file. Most people don't do that, but that is within the RFC. But let's just go over like what it looks like encrypted, because right now we see all this is set to nothing. So let's generate another key. So let's do keygen, and this time let's do it on a different panel. So keygen-f. I'm going to call it encrypted. And I'm just going to put IPsec for the username, not username password, but the passphrase is going to be IPsec. And then let's decrypt it. So cat encrypted. And then base64-d encrypted. And now we can run bless on encrypted.pt. And we have pretty much the same thing, except now it's encrypted. So if we look at this, this OpenSSH, it's the same exact magic byte or whatever you want to call this, and it's null terminated. This time, instead of 4, we get A, and A in hex is 10. So AES 256 CTR is going to be 0xA bytes, which is 10. So the next length, instead of 4, which was none, this is 6, and bcrypt is 6 characters long, right? So this is where we had the null bytes before, I think, right? Let's go back to the blog post. We do this. We got the cipher. We got the KDF. And now we have this. And if we look, this is going to be a size. Before, this was all nulls, and then it just stopped. But now we have 18. So this is going to be a length of 18. So I'm just looking for my selection right here. And this is, let's see, if we look at it, it's going to be a string salt and uint 32 rounds. So let's see. I'm going to guess 10. This is going to be the length of the salt. So the salt is probably going to go from this B2 to F0. Looking at it, 10 bytes. So there we go. That is the salt. And the next thing is 32 bits, which is 10. So this is going to be the rounds that it uses. And rounds, I think, is like a key stretching thing. So it just does this hashing function 10 times. Or 10 would be 17, I want to say, or 16. So yeah, let's go back to the unencrypted one. Because if we do the encrypted and keep going, it's going to be weird. SSH private keys contain a public key that we're about to talk about, but because it's encrypted, if we highlight this SSH RSA, we only see it once because it's got encrypted data down below, right? So we don't see that private key at all in it because it's AES encrypted. And then I guess the key is protected by I don't know encryption. So I'm just going to be quiet and let's go to the unencrypted version. So where were we? Let's find out where we're on the file. We see SSH RSA. This entire blob where my cursor is the public key. Then we got the private key down here. It is kind of weird that the private key file contains the public key, but let's move on from that. So I want to say 1, 2, 3, 4. This is the encryption information, which is null, so there's nothing there. Then this is the one key. Then we have 0197, and this is a length. And the length actually begins after SSH RSA. So we got one length here. We got another length that is telling us the length of this string, SSH RSA. And then if we go 0197, that's going to be the length of the public key. So I'm just going to highlight and drag it down. And if I'm looking at the selection, I'm at 0195. Boom. This will be most likely the public key. And I think I'm off by 1. So maybe there's a null byte here. I don't know exactly what this is. I say I'm off by 1 because I know the next piece is going to be a size. It's that SSH RSA again. And we see 00000007. So this is the public key. So maybe in an SSH private key file, each public key is separated by a null byte. I don't know exactly what it is, but I guess it is what it is. So let's see. We did 7 SSH RSA. Then we got to do a length. So actually, this isn't a null byte. This is where the part of the length. So I was just off by 1 when I was highlighting or something. Hopefully, it's somewhat easy to follow. So this is a length. It's going to be 3 because we have 32 bits here. It ends in 3. So this is going to be a value, this 010001. If we look at the post, let's see. After this, we have where the public key begins. That's going to be the RSA public exponent. And E is also used in the private key. So we see public exponent used twice. And if we scroll down, we can see it's also highlighted here. Right before it is 3 as well. So the exponent matches in both keys. So the next thing we have is another length, 0181. And that is going to be the variable n. So the variable n, let's click here and try to guess where it is. It's probably going to be somewhere here. I'm at 0188, so 0881 right here. And the other trick we could do, because n also exists in the private key, we could just highlight and abuse the fact that bless is going to tell us if there's a duplicate match. So we can kind of just drag the cursor around right here. Oh, doesn't match. It matches here. Our selection is 183 bytes, but keep in mind, right after it is a length, and most lengths are going to be 32-bit, and nothing's really long enough to have anything in these 2 upper bits. So easy way to kind of just figure out where you're at in a file. So that will be E and N. So now the next step is, let's figure out this. So this is going to be 0588. And in this post, it doesn't really say exactly what this is, but if we played with it a bit, we'd quickly figure out. So we're exiting the public key, and there's in the private key, there's 2 unsigned 32-bit integers. And if we look, for some reason, it must match with the previous one. I don't know exactly why, but if we highlight this, we can see it duplicated. So I'm going to guess 0588 is going to be some type of size. And it goes until the end of the file because we only have 1 private key. So I'm going to cheat and just start at the end, and we're going to highlight until we're at 0588 to see if this makes sense, right? So 0560, let's see, 05, no, B, oh crap. I was not holding shift. So let's do this again. Where's SSH RSA here? So 05 and then 88 right here. So the length starts right after this length field, and that's going to be the length of the first private key in this file. So we have the, what is it? Check integer. So two 32-bit integers that don't really mean that much. And then we begin with the length of SSH RSA. And after that, you have, I want to say it was N. If we go back here, yep, the RSA modulus variable N. And that was in the public key as well. And that's going to be 181 bytes. So if we just highlight, let's just do the cheating way. That's 139, 71, 81. So this is where N ends. And again, it's in the public key as well. Next thing, we have the exponent, and that was 010001. Okay. And then after that, we have 0180. So that's going to be, we just did NE. So this is going to be D in it. So we go 180, highlight, and go right here. So this is D, which is a private exponent, then IQMP, the RSA inverse, whatever these mean in RSA. We have the length of C. So this is a really small one. So let's just go to C. Is that it? My highlight, it says that is it, but it looks like more. So look at this. 1, 2, 3, 4. Oh, C0. So it's a bit bigger. So C0. You always know when, and you're in a file like this and you have the wrong bit when it's not like ending at a bunch of zeros. So next one is RSA prime 1, which is P. So let's look at this. This is going to be C1 in length. So let's go here. C1. And then we want Q. And this is going to be the magic one that we used in the video. The only piece that really mattered in the private key, because once we got P or Q, we could derive the other things. So 0000C1. So go here. And we got this. And then one piece that I didn't know that was in private keys, if we look at the end, we can see the comment, which is my username @machine. So if you ever came across, like you just found a random private key somewhere on a network and you wanted to know where it goes, just base64 decode the private key, look at it, and you may kind of get a hint because you'll be able to see who generated or where it generated from, right? So this length is 0D. And if we highlight all of this, the 0D is right here. And it's just IPsec at Ubuntu. And then it ends with just random padding. So 1, 2, 3, 4, 5, 6. I don't know how it determines padding, but yeah. So now that we know all of this, let's just grab information out of the public key, the ENN, and then we'll get Q and generate a certificate that we can log in with, right? So let's copy the public key over to my SSH directory. So I'm going to cp unencrypted.pub to .ssh authorized keys, and then chmod 600, that file. So now if someone has the private key, they should be able to log into this machine. Let's get all the exponents out. So the very first thing I want to do is get two things out of the public key. And I know I said the public key is like, I think this chunk right here, but you kind of taken my word for it, right? So let's get E and N out of the actual public key file. So let's cat unencrypted.pub, and then we can awk print 2 base64-d to unencrypted.pub.pt. And then I'm going to run bless on that file to open it, and really hope that the public key is in the same exact format, because I have not tested this out. So this could be demo gods. So we have SSH RSA. Interesting enough, there's no like magic byte or anything here. So we got 3, and then the exponent is going to be 010001. So I'm going to go over to my parrot box, I'll call this notes.ssh.text, I guess. And we're going to say E0x010010. I think that was. It was 1 null byte 10. 1 null byte 1. Okay. So the null byte, come on, click. There we go. So we got E there. Then let's get N, right? So N is going to be 181 bytes. So let's go here. Oh, it's just the rest. So if I just copy, I wonder if this copies all the hex. It does. 0x. What if I can do like this? That did not work. %s. Let's do a G. There we go. We just got rid of all space in the file, but that's fine. So these are the two values in the public key file, right? So we want Q next. So let's go over here, go to the private key, and we want Q. I wish I was doing this as I did it, but I think Q was the very last one. So if we just backtrack a little bit, so we have the comment here, then we got the length, and then Q is going to go up until some more null bytes, right? So C1. I'm guessing this is all Q. So if we grab this to D7, let's hope. Let's see. That was C1. We're at C1, C1 bytes. Yeah, that looks like Q. That's a Q to me. So let's paste this in and do 0x. And now's the moment to place your bets. If we've done this all correctly and can generate the private key very first time. So we have notes, SSH, text of all of this. And now we just run the RsaCtfTool. So -E, copy and paste, -N, you got it, copy and paste, and then Q. And the final thing is we just tell it we want the private key, so --private, and we get a key out. So let's copy, create a file called key, chmod 600 on key, then we can SSH, so SSH-I IPsec at, what is the IP address of this Ubuntu box? So IP-ADDR, 192.168.58.175. So moment of truth right now, and denied. Let's add a -V. Let's see. We're attempting keys. let's see what the fingerprint of this key is. So SSH Key Gen -L -F. The -F is file. And now we got to give it the public key, or the public key to this. And let's see, CK. So this is going to be the fingerprint we used. And I don't see that fingerprint actually. CK, it's not using it. Let's see, -O, identities only equals yes. There we go. And I bet if we scroll up, we'll see the CK key that we used. That's server host key. Let's see. Logging in. Found key. Where is it? Authentication that can continue. It's not telling me the fingerprint. That is bizarre. This is definitely the server host key. So I think what happened is I just have too many keys on my host, and for some reason, it never accepted the key, like the key when I did -I. But we can see we definitely logged in with that. I would expect us to say the handshake of, like, what is it? CKSX. But I did not see that anywhere. Let's see. Easy way to do this. I'm going to copy this command. Run tmux. Paste it. And now we can search the pane for something. So I'm just going to copy a few characters. Search up. And we don't see it. So I'm not sure exactly how to show you exactly what went wrong. I bet if I used a user that didn't have as many SSH keys in my SSH directory, it would have worked just fine. Let's see if that is true. I can prove that. So let's do sudo mv.ssh.ssh.back. Go back to this directory. We can get rid of this -O options because I only have one key now. So if I do this, yes, and we get logged in. So I just have too many keys in my SSH directory. Apparently that causes an issue. Anyways, the last thing I wanted to show off is just how small the actual important piece of a private key is if you have the public key, right? So let's do notes, ssh.text, and we can grab this. And if I do, actually I don't want the 0x. So if we just do echo -n, paste in the hex, ends in D7, xxd-r-p. This is just going to reverse it from hex. We're going to get a bunch of gibberish, but if we base 64 it, Q in this key consists of about 4 lines of base 64. If we look at the private key, so let's go cat key, grep-v, anything that begins with this. Let's get only lines, wc-l. So 4 lines out of 37 of the private key actually matters and sensitive. So you can imagine if anyone is just taking a screenshot of a private key in a pen test report and censors a bunch of the top out thinking they did a good job, the sensitive prime numbers are somewhere in here. So you can still extract that from the report, which I think is really cool. And I know I said one more thing, or that was the last thing. However, I'm really curious what the RsaCtfTool puts as a comment in an SSH key. Can we actually flag keys that are created by this tool? I don't know. So let's base 64-d, xxd it, and I don't think it puts a comment. Let's see. What am I looking at? This is the key. Base64 XXD. I'm guessing this is the padding, right? So I don't think it actually puts a comment at all in the key. So it's probably a way you can identify if this was created with the like SSH Key gen file. I guess that's interesting, right? I'm trying to find what like where the comment would even be in this. It may just stop at the key. Let's see. Let's look for 4 zeros. I screwed something up, didn't I? This, base64-D, XXD less. We don't have... the SSH magic. So, yeah, this is weird. I don't know how else to say it. I guess this is why I do videos, right? Because I always learn things. I didn't think to do, like, when I was playing with this, I didn't think to experiment and see what, like, the key looks like from this tool, right? But everything we pretty much learned is out the window with how it creates this key. So I'd have to look more into exactly what RsaCtfTool is doing to continue this, because I don't even see like 32-bit integers, right? Like, this looks bizarre to me. If we less key, begin RSA private key. Does this say yeah. So it creates an RSA private key, not an open SSH private key. So that's probably the difference. So this is a completely different key, but SSH is able to use it. So I guess that's cool. And that's why we don't see any of those fingerprints. So if you see people authenticating the SSH without a like SSH key and just begin RSA private key, maybe it's interesting, maybe it's not. I don't know. Because this string is in any type of RSA key. So it's probably not interesting. It's interesting to me. I don't know exactly what to make of it, but that is the conclusion of my video. So hopefully you enjoyed this. Thank you for listening to random rumbling and ranting. But yeah, see you all next time.